Hi everyone, it's Miss Berry again. We're going over the last section. So exciting. Section 10.4 is called Hypothesis Testing for a Population Proportion. So I'll share my screen and get started. All right, there we go. This one's going to be a little bit shorter because we've already went through the, whoops, wrong one. We went through the hypothesis test process 3 times already, so we'll just skip right on through the 4 steps and get right into the problem. So this is going to be very similar. However, you're going to notice that we don't see the word mean anywhere. Right, so you're going to notice as we read the problem that we don't see the word mean. Oftentimes you will see a percentage, and so that's kind of like your indicator for what type of hypothesis test it is. All right, so it says one study claimed that 92% of college students identify themselves as procrastinators. A professor believes that the claim regarding college students is too high. The professor conducts a simple random sample of 137 college students, and they find that 119 of them identify themselves as procrastinators. So 119 out of 137. Does this evidence support the professor's claim that fewer than 92% of college students are procrastinators? Use a 0.05 level. All right. So let's start writing our HO, our HA, let's see what else. We're going to need our level of significance. So notice that nowhere in here did we see the word mean. We did see some percentages, so that tells us that we're dealing with we're estimating a population proportion, or excuse me, we're testing a claim about a population proportion. Right, so we talked about that back in 8.4, so you may remember it from there. All right, so the symbol for population proportion is just lowercase p, and we still have the equal to in the null hypothesis. So this professor, or excuse me, the value that's currently believed to be true is that 92% of college students are procrastinators or self-identify as procrastinators. So as a decimal, that would be 0.92. And then this professor believes that less than 92% of college students are procrastinators. So they state that twice, just in different ways. First, they say that the professor believes that the claim is too high. And then later on, they describe that as fewer than 92%. So we're going to say less than 0.92. And they told us to use a 0.05 level of significance. All right, so just like when we were doing confidence intervals, if you are doing a hypothesis test for a population proportion, the option that we're going to use in the calculator is called one prop Z test. If you remember when we did the confidence intervals, it was called a one prop Z interval. So this one's called a one prop or one proportion Z test. All right, and so the 2 things that you're going to need whenever we go to type this in, or actually I think we need, maybe just the 2 things. They're going to ask for X and then N. X is what they call the successes. Now, success is going to vary based on what you're looking at. So this is the number of successes. And then N, of course, is the sample size. All right. All right, so N is our sample size. That is 137. She said, or the professor surveyed 137 students. Number of successes in this case would be people that self-identify as procrastinators, since that's what we're looking at. And they said that 119 of those surveyed self-identified as procrastinators. All right, so I think that's everything we'll need. Let's go jump to our calculator. We're going to over to test, and option 5 is one proportion Z test. All right, hit enter. We've got our null hypothesis, so we believe that 92, the value currently believed to be true is 92%. X is, what do we say, 113? I think that's right, but you aren't here to tell me. 119. Good thing we checked. 119. And then what was our sample size? 137. 137. All right. And then the alternative hypothesis was that it was less than 0.92. All right, then go down to calculate and we'll grab our p-value. There's our test statistic up there, negative 2.22. And then there's our p-value, 0.01. 0.01. Okay. P is 0.01. All right, we're ready to make our to draw our conclusion. You're asking yourself the same question or using the same sort of phrase to remind yourself. If P is low, reject HO. All right, so is P less than alpha? P is 0.01, alpha was 0.05, yes. That's 1% and 5%, so yes, absolutely. 1% is less than 5%. All right, so we're going to reject HO. And let's interpret that decision. If we reject HO, we say there is sufficient evidence. There is sufficient evidence at the 0.05 level of significance to suggest, and then let's restate the alternative hypothesis. Fewer than 92% of college students are procrastinators. To suggest that fewer than 92% of college students are procrastinators. All right. So hopefully you're starting to get the hang of this and you feel comfortable with the process and sort of scaffolding this in your head and doing, the null and alternative first, write the level of significance, figure out the test type, figure out what do I need to type in, grab the p-value, make a decision. All right, and our last problem for the whole class. The National Academy of Science reported that 44% of research in mathematics is published by U.S. authors. The mathematics chairperson of a prestigious university wishes to test the claim that this percentage is no longer 44%. He has no indication of whether the percentage has increased or decreased since that time. He surveys a random sample of 190 recent articles published by reputable math journals, and he finds that 87 of those have U.S. authors. Does this evidence support the mathematics chairperson's claim that the percentage is no longer 44%? Use a 0.01 level of significance. All right, so HO, whoop, wrong one. HO, HA, alpha. All right, so again, we did not see the word mean anywhere in here. We're dealing with percentages, so we think this is a proportion, so we're going to do P. Null hypothesis gets the equal to. And the value that's currently believed to be true is 44% or 0.44. And this mathematics chairperson believes that it's no longer 44. He doesn't know if it's increased or decreased, so they don't know if it's lower or higher. They just think it's not 44% for whatever reason. All right, and then our alpha level, they said 0.01. All right, and remember, just like last time, we are doing a one prop z-test or one proportion z-test. So we're going to need our number of successes and our sample size. Sample size was 190. And out of that 190, 87 were successes. They had U.S. authors. All right, so let's plug that in and we'll grab the p-value. Okay. 0.44, 0.01, 87, 190. Let's see if I can remember it. Stat test, down to option 5. Sorry, I went through that kind of fast. So stat, and then over to test, and then down to option 5. 0.44 was the value that's currently believed to be true. Yep, I have already forgotten. All right, so 87 and 190. 87 and 190. 190. All right, and then the chairperson thinks that it's no longer 44%. They don't know if it's lower. They don't know if it's higher. So we're just doing not equal to. Then we're going to hit calculate, grab our p-value. There's our test statistic. It's about 0.50. Whoa, p-value, super high, 0.6. 0.6. Forgot to grab the other decimal place. I was so taken aback. 0.62. 0.62. So you're going to ask yourself or remind yourself, if P is low, reject HO. All right, so is P less than alpha? Is 0.62 less than 0.01? Absolutely not. That's like 62% and then 1%. So definitely not less. All right, so we're going to fail to reject HO. All right, so let's write our sentence. Remember, when we fail to reject, we say there is insufficient evidence. And then you got to put the level of significance. So at the 0.01 level of significance to suggest that, and then we restate the alternative hypothesis. And let's see that the percentage is no longer 44%. That the percentage is no longer 44%. Cool. All right. Let me switch back over. If you're still writing that down, of course, you can pause it. All right. We'll switch back over. Stop sharing my screen. Hi. It has been such a pleasure having you guys in my class this semester. I hope that you have learned something from this class. And as always, if you have any questions, please let me know. And I hope you guys have a great break.